Section 680.21 addresses specific requirements for wiring installations near or associated with swimming pools. It focuses on the limitations of installing wiring in concealed spaces. The section states that wiring cannot be installed in concealed spaces such as hollow walls, ceilings, attics, roof spaces, and crawl spaces. There is an exception to this rule. Wiring can be installed in concealed spaces when it is necessary for the proper operation of the pool equipment and the concealed spaces are accessible. The key aspect of Section 680.21 is the prohibition of wiring in concealed spaces unless specific conditions are met. This is primarily aimed at ensuring safety and accessibility for maintenance and inspection. When considering the application of Section 680.21 to a gas pool heater, several factors must be considered. Firstly, the location of the gas pool heater is crucial. Gas pool heaters are typically installed outdoors. If the heater is indeed installed outdoors and the wiring is exposed, then Section 680.21 would generally not apply. The rule primarily concerns wiring within concealed spaces, not exposed outdoor wiring. Secondly, if the gas pool heater requires any wiring to pass through concealed spaces to reach its power source or control systems, then Section 680.21 would need to be carefully considered. For example, if the wiring runs through a wall or ceiling to connect to the electrical panel, it would need to comply with the requirements of the section. Thirdly, the accessibility of the concealed spaces plays a significant role. If the wiring is run in an accessible concealed space, such as an attic or a crawl space with easy entry, and is necessary for the pool heater's operation, then it may be permitted under the exception provided in Section 680.21. Accessibility implies that the wiring can be inspected and maintained without significant difficulty. Fourthly, any wiring installed in concealed spaces must be done in accordance with other applicable sections of the National Electrical Code or NEC. This includes using appropriate wiring methods such as conduit or suitable cable types, and ensuring proper grounding and overcurrent protection. The NEC provides detailed guidelines for safe wiring practices, and these must be followed in addition to the specific requirements of Section 680.21. Fifthly, it's also important to note that local electrical codes or regulations may have additional requirements or restrictions beyond those specified in the NEC. Always consult with the local authority having jurisdiction or AHJ to ensure full compliance with all applicable codes. To summarize, Section 680.21 prohibits wiring in concealed spaces unless it is necessary for the operation of the pool heater and the concealed spaces are accessible. If the gas pool heater is installed outdoors and the wiring is exposed, this section typically does not apply. However, if any wiring runs through concealed spaces, it must comply with the accessibility requirements and other applicable NEC provisions. Always consult with a qualified electrician and the local AHJ to ensure compliance with all relevant codes and regulations. Understanding wiring methods is crucial for safe electrical installations. Several approved wiring methods are used in residential and commercial buildings. Each has unique characteristics and applications. Firstly, non-metallic sheet cable, often referred to as NM cable or Romex, is commonly used for residential wiring. It consists of two or more insulated conductors and a grounding conductor wrapped in a non-metallic sheath. NM cable is suitable for dry locations within walls, floors, and ceilings. It is relatively easy to install and is a cost-effective choice for many residential applications. Secondly, electrical metallic tubing or EMT is a thin-walled metal conduit used to protect conductors. EMT is typically made of steel or aluminum and is joined using fittings. It provides good physical protection for wiring and can be used in both exposed and concealed locations. EMT is often used in commercial and industrial buildings. Thirdly, rigid metal conduit or RMC is a thick-walled metal conduit that offers superior protection for conductors. RMC is typically made of steel and is joined using threaded fittings. It is suitable for use in harsh environments or where significant physical protection is required. RMC is commonly used for outdoor applications or in industrial settings. Fourthly, flexible metal conduit, or FMC, is a flexible metal conduit that allows for bends and movement. FMC is often used to connect equipment or appliances where flexibility is needed. It is available in both liquid-tight and non-liquid-tight versions. Fifthly, armored cable, or AC cable, also known as BX cable, consists of insulated conductors wrapped in a flexible metal armor. AC cable provides good physical protection for wiring and can be used in both dry and concealed locations. It is commonly used in older homes and for certain commercial applications. When selecting a wiring method, several factors should be considered. This includes the environment, the type of building, the applicable codes and regulations, and the budget. The environment includes factors such as moisture, temperature, and exposure to chemicals or physical damage. The type of building includes residential, commercial, or industrial. Applicable codes and regulations such as the NEC or local electrical codes dictate the allowable wiring methods. Budget is a practical consideration, as different wiring methods have varying costs. It's important to follow all applicable codes and regulations when installing electrical wiring. Proper installation techniques are essential for safety and reliability. Always consult with a qualified electrician if you have any questions or concerns about electrical wiring. Grounding and bonding are essential safety measures in electrical systems. They help to protect people and equipment from electrical shock and damage. Grounding refers to connecting the electrical system to the earth. This provides a low impedance path for fault current to flow back to the source. It helps to trip the circuit breaker or fuse in the event of a fault, preventing electrical shock. Bonding refers to connecting all metal parts of the electrical system together. This includes metal conduits, enclosures, and equipment. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Several components are used in grounding and bonding systems. Firstly, a grounding electrode is a conductor that is buried in the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The grounding electrode provides a connection to the earth for the grounding system. Secondly, a grounding conductor is a conductor that connects the electrical system to the grounding electrode. The grounding conductor is typically made of copper or aluminum. It must be sized according to the applicable codes and regulations. Thirdly, a bonding jumper is a conductor that connects metal parts of the electrical system together. Bonding jumpers are typically made of copper or aluminum. They must be sized according to the applicable codes and regulations. Fourthly, a ground fault circuit interrupter, or GFCI, is a device that detects ground faults. A GFCI trips the circuit if it detects a ground fault, preventing electrical shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Proper grounding and bonding are essential for electrical safety. They help to protect people and equipment from electrical shock and damage. Always follow applicable codes and regulations when installing grounding and bonding systems. Consult with a qualified electrician if you have any questions or concerns about grounding and bonding. Overcurrent protection is a critical aspect of electrical safety. It protects electrical circuits and equipment from damage due to excessive current flow. Overcurrent can be caused by short circuits, overloads, or ground faults. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. Circuit breakers are electromechanical devices that automatically trip and interrupt the circuit when an overcurrent condition occurs. They can be reset manually after the fault has been cleared. Fuses are overcurrent protection devices that contain a fusible link that melts and breaks the circuit when an overcurrent condition occurs. Fuses must be replaced after they have blown. Circuit breakers and fuses are rated in amps, which indicates the amount of current they can carry before tripping or blowing. It's essential to select the appropriate overcurrent protection device for the circuit being protected. The amp rating of the overcurrent protection device should match the ampacity of the conductors in the circuit. Overcurrent protection devices should be installed in readily accessible locations. This allows for easy inspection, testing, and replacement. Regular inspection and testing of overcurrent protection devices are essential to ensure they are functioning properly. Faulty or improperly sized overcurrent protection devices can lead to electrical fires or equipment damage. Several factors should be considered when selecting overcurrent protection devices. These factors include the circuit ampacity, the type of load being protected, the available fault current, and the applicable codes and regulations. The circuit ampacity is the maximum amount of current the circuit can safely carry. The type of load being protected includes resistive loads, inductive loads, and capacitive loads. The available fault current is the amount of current that would flow in the event of a short circuit. The applicable codes and regulations such as the NEC dictate the requirements for overcurrent protection. Proper overcurrent protection is essential for electrical safety. It helps to protect electrical circuits and equipment from damage due to excessive current flow. Always follow applicable codes and regulations when installing overcurrent protection devices. Consult with a qualified electrician if you have any questions or concerns about overcurrent protection. Electrical codes and standards play a crucial role in ensuring the safety and reliability of electrical installations. These codes and standards provide guidelines and requirements for the design, installation, and maintenance of electrical systems. The NEC is the most widely adopted electrical code in the United States. It is published by the National Fire Protection Association or NFPA and is updated every 3 years. The NEC covers a wide range of electrical topics, including wiring methods, grounding, overcurrent protection, and equipment installation. UL is a global safety certification company that tests and certifies electrical products. UL listing indicates that a product has been tested and meets UL safety standards. Electrical products that are UL listed are generally considered to be safer and more reliable. NEC is a private, non-profit organization that develops and publishes voluntary consensus standards. NEC standards cover a wide range of topics, including electrical safety, performance, and testing. AE is a professional organization for electrical and electronics engineers. IEE develops and publishes standards related to electrical power systems, telecommunications, and information technology. The electrical codes and standards are constantly evolving to address new technologies and safety concerns. It's essential for electricians and electrical contractors to stay up to date on the latest codes and standards. Compliance with electrical codes and standards is essential for electrical safety. It helps to protect people and property from electrical hazards. The authority having jurisdiction, or AHA, is responsible for enforcing electrical codes and standards. The AHA may be a local, state, or federal agency. The AHA has the authority to inspect electrical installations and to require corrective action if necessary. Staying informed about electrical codes and standards is crucial for anyone involved in the electrical industry. Regular training and education are essential for maintaining competence and ensuring compliance. Several resources are available for learning about electrical codes and standards. These resources include the NEC Handbook, UL publications, and IEE standards. Proper adherence to electrical codes and standards is paramount for electrical safety. It ensures that electrical installations are safe, reliable, and compliant with industry best practices. Always consult with a qualified electrician and the local AHA to ensure compliance with all applicable codes and standards. Working with electricity can be dangerous, and it's essential to follow safety precautions to prevent electrical shock and other injuries. Always de-energize the circuit before working on electrical equipment. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use insulated tools when working on electrical equipment. Insulated tools help to protect you from electrical shock. Wear appropriate personal protective equipment or PPE, such as safety glasses, gloves, and footwear. PPE helps to protect you from electrical hazards. Never work on electrical equipment in wet or damp conditions. Water is a good conductor of electricity and can increase the risk of electrical shock. Be aware of your surroundings and avoid contact with overhead power lines or other electrical hazards. Maintain a safe distance from energized electrical equipment. Use a voltage tester to verify that the circuit is de-energized before working on it. A voltage tester can help to prevent accidental contact with live wires. Follow lockout/tagout procedures to ensure that the circuit remains de-energized while you are working on it. Lockout/tagout procedures involve placing a lock and tag on the circuit breaker or fuse to prevent it from being accidentally turned on. Never bypass or disable safety devices, such as ground fault circuit interrupters or GFCIs. Safety devices are designed to protect you from electrical shock. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Working with electricity can be dangerous, and it's best to leave it to the professionals if you are not properly trained. Regular safety training is essential for anyone who works with electricity. Safety training can help you to identify electrical hazards and to follow safe work practices. Always follow applicable codes and regulations when working with electricity. Codes and regulations are designed to ensure electrical safety. Proper electrical safety practices are essential for preventing electrical shock and other injuries. Always prioritize safety when working with electricity. Working with electricity requires a thorough understanding of electrical principles. These principles govern how electricity behaves and how electrical circuits function. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Voltage is often described as the electrical pressure that drives current through a circuit. Current is the flow of electrical charge through a circuit. It is measured in amps. Current is often described as the electrical flow that is driven by voltage. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Resistance is often described as the electrical friction that impedes current flow. Ohm's law is a fundamental law of electricity that relates voltage, current, and resistance. Ohm's law states that voltage is equal to current multiplied by resistance, or volts equals amps times ohms. Power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. Power is equal to voltage multiplied by current, or watts equals volts times amps. Series circuits are circuits in which components are connected in a single path. In a series circuit, the current is the same through all components. The voltage drops across each component add up to the total voltage of the circuit. Parallel circuits are circuits in which components are connected in multiple paths. In a parallel circuit, the voltage is the same across all components. The current through each component adds up to the total current of the circuit. Understanding these basic electrical principles is essential for working safely and effectively with electricity. It allows you to analyze circuits, troubleshoot problems, and design electrical systems. Further study and training can deepen your understanding of these and other electrical concepts. It is also important to consult relevant codes and standards, such as the NEC, to ensure that your electrical work is safe and compliant. Always consult with a qualified electrician if you have any questions or concerns about electrical principles or practices.